So session one is entitled Linear Equations in One Variable. We're going to start with a definition. So my definition for a linear equation in one variable. A linear equation in one variable is an equation that can be written in the form of ax plus b is equal to 0, where where a and b are real numbers and a is not 0. So this is my definition. A linear equation in one variable is an equation that can be written in this form: ax plus b is equal to 0, where a and b are real numbers and a is not 0. Okay, some examples would be x plus 1 is equal to negative 2. Of course, this is of that form. X minus 3 is equal to 5. This is also an example. Another example would be 2x plus 5 is equal to 10. So these are three examples that look like this. And so I want you to be aware of that bottom condition, a is not 0. That condition is very important because if a is 0, then notice I have 0x, and then I won't have a variable at all. So that bottom condition is very important. So now that we have a definition of a linear equation in one variable, let's learn how to solve. And so when we're solving these, notice that on each side we have an expression. We have a left side and a right side. In order to solve an linear equation in one variable, we want the variable on one side. In this case, we want our x on one side, and we want our constant term on the other side. So I know I'm done solving when I have x is equal to some number, or when some number is equal to x. Just for a basic example, suppose I gave you x minus 3 is equal to 5. And so we're going to use additive inverses to solve this equation, x minus 3 is equal to 5. And so my left side is x minus 3. My right side is 5. And so the goal is to isolate my variable x. And to isolate x means to get x by itself. Well, what's on the same side with x? The minus 3. So we're going to use our properties of addition and multiplication by doing the additive inverse. So I have minus 3. To get rid of it, I'm going to plus 3 on both sides of my equation. So that plus 3 and that minus 3, they subtract out, and we have x is equal to 8. So this is a really basic example. We want to use this idea to solve these equations. So my very first example says solve 4x minus 2x minus 5 is equal to 4 plus 6x plus 3. So 4x minus 2x minus 5 is equal to 4 plus 6x plus 3. Okay? So notice that I have multiple terms on both sides of my equations. So your very first step is to combine like terms. So my first step is to combine like terms. So looking at the left side of the equation, my like terms are 4x minus 2x. So if I combine those, I will have 4x minus 2x is 2x. And bring down to minus 5. On the right side, my like terms are 4 and 3. And I need to add those together because it says plus 3. So 4 plus 3 is 7. Bring down the positive 6x. All right. My second step would be is to isolate my variable x. So let's isolate x. And so I like my variable on the left side of my equation. So I'm going to leave my 2x alone, and I'm going to move my 6x. It says plus 6x. I'm going to do the additive inverse by subtracting 6x on both sides. So those subtract out. 2x minus 6x is negative 4x. I'm going to bring down that minus 5. It's now equal to 7. My third step is to isolate my constant. So in other words, I want my numbers on the right side. So I have minus 5. So I'm going to add 5 to both sides. So now I have negative 4x is equal to 12. And the last step is divide by the coefficient of x. So x must be negative 3. So my solution is negative 3. Okay, so let's do another one. We're going to speed it up just a bit. Second problem says solve two groups of x minus 5 plus 3x is equal to x plus 6. Okay, so notice I have parentheses on the left side. So what I want to do first is distribute the 2. So we're going to take the 2 and multiply it by everything inside the parentheses. 2 times x is 2x. Minus 10. 2 times 5 is 10. Plus 3x is equal to x plus 6. Let's follow those same steps. We have like terms on the left side. 2x plus 3x. Now we have 5x minus 10 is equal to x plus 6. All right, let's isolate our variable x. I prefer my x to be on the left side, so I move the 1 off the right. So I'm going to subtract x on both sides, line it up with the other x. Those subtract out. So now we have 4x minus 10 is equal to 6. Let's isolate our constant, put our constants on the right side, add 10 to both sides. Those subtract out. 4x is now equal to 16. Now we divide by 4. X must be 4. And so there we have it. Let's do one more. Solve 4 groups of 3x minus 2 is equal to 38 minus 2 groups of 2x minus 1. Same idea applies. Let's distribute first. 12x minus 8 is equal to 38 minus 4x plus 2. Be careful here. It's negative 2 times a negative 1. We distribute a negative 2 here. Okay. I have like terms on my right side. My constant terms, 38 plus 2 is 40. So I have 12x minus 8 is equal to 40 minus 4x. All right, let's isolate our variable x. I'm going to add 4x to both sides. So I have 16x minus 8 is equal to 40. And let's add 8 to both sides. All right, those subtract out. So I have 16x is equal to 48. Divide by 16, x is 3. Okay. And so we can always go back and check our work. To check our work, we'll take our solution 3 and we'll plug it into the original equation. So let's check this one. We're going to check this. So check. My original equation said 4 times 3x. Instead of writing x, I'm going to write my solution 3. So it's 4 times 3. Well, 4 times 3 groups of 3 times 3 minus 2 is equal to 38 minus 2 groups of 2 times x. X is 3 minus 1. Everywhere I had x, I replaced x with my solution 3. And so in order for this to check a solution, we must have the same thing on both sides. The left side must equal the right side. That's how we know we did it right. All right, and so if we simplify this, we'll have 4 times 9 minus 2. Is that equal to 38 minus 2 times 6 minus 1. And so 4 times 7, is that equal to 38 minus 2 times 5. We have 28 on this side. Is that equal to 38 minus 10? We do have 28 is equal to 28. So it checks out. So we solved it right. Okay. Our next type of problem says solve x plus 7 over 6 plus 2x minus 8 over 2 is equal to negative 4. We're going to solve this one here. So I know we don't like fractions, so what we're going to do is we're going to get rid of our fractions. So we look at our denominator 6 and 2, and what we do is we find our least common multiple of our denominator 6 and 2. To find the least common multiple, what you do is you write out the multiples of 2's and you write out the multiples of 6. So the least common multiple of 6 and 2, let's write out the multiples of 2's. 2, 4, 6, 8, 10, 12, so forth. Let's write the multiples of 6, 6, 12, 18, so forth. The first number we see in common is 6. So my least common multiple is 6. So now that I have my least common multiple, I'm going to multiply all terms in this equation by 6. So notice that I have 3 terms, so each term is going to be multiplied by 6. So I'm going to say 6 times that first term, x plus 7 over 6, plus 6 times the second term, 2x minus 8 over 2 is equal to 6 times that third term, negative 4. So everything on the board, or everything on in this problem must be multiplied by the least common multiple. And this is going to get rid of those denominators, those fractions. And so notice that I'm multiplying and dividing by 6. So these divide out, and I'm left with x plus 7. All right? And so now notice that 6 divided by 2 is 3. And so this leaves 3 groups of 2x minus 8. Multiplying 6 by negative 4, we get negative 24. Okay? And now I can solve this. Distribute the 3, x plus 7 plus 6x minus 24 is equal to negative 24. Like terms, x and 6x makes 7x. Okay, I just added x and 6x. And now my 7 minus 24 is negative 17 is equal to negative 24. Adding 17 to both sides. 7x is equal to negative 7 divided by 7. X is equal to negative 1. And so my solution is negative 1. Okay, so that one took a little work. Let's do one more to make sure we have it. So we're going to solve, let's find one, x minus 4 over 8. Sorry, let's do, we're going to do x minus 4 over 4 plus 2x plus 4 over 8 is equal to 5. So I'm going to encourage you to pause the video here and give this a try by yourself. And once you get it, go ahead and check it work and watch me work it out. And so notice that my least common multiple of 4 and 8 is going to be 8. So I'm going to multiply everything by 8. So I'm going to multiply the first term by 8, second term by 8, and that 5 by 8. And so we have the following. So 8 divided by 4 is 2, and leaves us x minus 4 in parentheses. These x divide out and left with 2x plus 4 is equal to 40. Distribute 2. 2x minus 8 plus 2x plus 4 is equal to 40. Adding my like terms, 4x minus 4 is equal to 40. Adding 4 to both sides, we have 4x is equal to 44. Dividing by 4, x is 11. And there we have it. So to finish this session, we're going to talk about 3 types of linear equations. So we have 3 types. My first type is called a conditional equation. So everything we did so far is called conditional. These have one solution. And then x is equal to some number. We say x is equal to some number a. A is whatever that number is. and that number is the solution. It has one solution. My second type is called the identity. All right, so we're solving this, and we see that we have the same number on both sides. We get a true statement. For example, A is equal to A. A is just a number. So if I had 1 on the left side, I should have a 1 on the right side. I should have a true statement, the same number on both sides. And these have infinite many solutions. And if I have infinite many solutions, I say that my solution set is all real numbers. That's from negative infinity to positive infinity. My solution set is all real numbers. And so my third type and final type is going to be called a contradiction. And these will give you a false statement. I have A is equal to B. So in this case, I might have two numbers like 2 is equal to 3, which is never true. It's a false statement. And so these have no solution. And we'll say that solution is the empty set. So these are my 3 types. So let me show you an example. Let's say I'm solving some problem, and I finish it up and I see that I have x is equal to 0. This is a type of problem that most people kind of mess up on. So is x equal to 0? Is this conditional, identity, or a contradiction? Well, notice that I see x is equal to some number. What is my solution? 0. 0 is the solution. So this is a conditional equation. It has a solution. The solution is 0. So this is conditional. It has one solution. That solution is 0. My second example is going to be 5 groups of x minus 3 is equal to 5x minus 15. All right, let's work this one. We'll distribute our 5. We get 5x minus 15 is equal to 5x minus 15. You can actually stop here because we notice that we have the same thing on both sides. They're identical. And so this must be the identity. All right, so this one is going to have an infinite many solution. That means that any value of x will satisfy this equation. So any real number is a solution to this equation. But let's just finish it off. I like my x on the left side, so I subtract the 5x off the right. Notice that they both subtract out. I get negative 15 is equal to negative 15. This is always true. We get a true statement for this. So this is the identity. And my solution set is all real numbers. So any number I choose, any real number I choose can satisfy this equation. So any real number is a solution. And so let's show you a contradiction. Suppose I had 5 times x minus 3 is equal to 5x minus, let's just say 12. All right, notice if I distribute, I get 5x minus 15 is equal to 5x minus 12. Subtracting 5x on both sides, we get negative 15 is equal to negative 12. Notice that this is a false statement. This is never true. So since I get a false statement, I reach a contradiction. And this is no solution. This has no solution.